Today we're going to be talking about this example in which a fair die will be tossed until it lands a value of a 3 or a 5. So success I'm going to define as 3 or 5, and in this instance the probability of success, because it can occur in two ways and there are 6 outcomes of the die. That's 2/6 or 1/3. Okay. I'm also going to define a random variable x, which is the number of the tosses of the coin, or excuse me, of the die until success. Okay. So I'm going to make a table of x versus p of x. You have to toss the die once in order to get success. So that indicates that that's the 1/3 probability outcome. You get success on the first toss. So on the first toss, you got success, or you can have failure. So this is 1/3, that's 2/3. On the second toss of the coin, you can have success, or you can have another failure. So this would be probability x equals 2. That means that the first toss was a failure, the second toss was a success, so that'll be 1/3 times 2/3. Yeah, okay. For 3 tosses of the coin, that would mean that you got success on your third toss of the coin. So P of x equals 3 means that the first was a failure and the second was a failure and the third was a success. Okay? Because these are independent and we have the and statement, we can multiply them. So this will be probability of failure times probability of failure times probability of success. Okay, and that will be 1/3 times by 2/3 squared. Okay. I think that we're starting to spot a trend here. So, for instance, what is the relationship here between the value of x and the exponent? Well, it's 1 less. So this would be 2/3 to the k minus 1 times by 1/3. Okay. And so this gives us a general formula for having k successes. That will be 1/3 times by 2/3 to the k minus 1. Okay. And this is the probability of having k successes, of having k tosses of the die until we get our success. Okay, so we're asked a couple questions here. What's the probability it takes exactly 4 tosses of the coin to land 3 or 4? So to answer A, this is just probability x, and it said 4 tosses of the coin, so excuse me, probability x equals 4, which will be 1/3 times by 2/3 to the 4 minus 1, and that's the exact probability. Now the second question asks, what's the probability it takes 10 tosses or less for this to happen. So in part B, it asks us, what's the probability x, and let me just double check, x is less than or equal to 10. So I get the success on less than 10 tosses or trials. Well, this would be the sum from x equals 1 to 10 of 1/3 times by 2/3 to the x minus 1. And we can remember this. This is a geometric sum. And I should add one other critical word there, which is a finite geometric sum. So the sum of this is just going to be 1/3 times by 1 minus 2/3 to the 11th power divided by 1 minus 2/3, and this quantity happens to cancel with that 1/3. We're going to get 1 minus 2/3 to the 11th power. Okay, and that's the exact probability, just using that as a geometric sum. Okay. Now, one last thing is, what if the probability of success changes? Well, what's the general formula? So in general, for a geometric series, the probability is going to be represented as p times by 1 minus p to the x minus 1. And that's for a geometric probability. Okay. F of x, which is the cumulative, is going to be 1 minus 1 minus p to the x plus 1. And let me just check one thing here. This should be just to the x, and this should be to the 10th power. So I just made a small mental arithmetic error here. Okay, so just a correction. So these are the cumulative and density functions. One last thing is, when can we apply this? Well, when can we apply these formula? Well, there's some criteria. One is that we need to have what's called a Bernoulli trial. We need to have a Bernoulli trial, which means, i.e., a success or failure outcome. Okay. The second thing is, each trial in this case, the toss of the die needs to be independent, meaning one toss should not affect the other, which we clearly have. Okay. The third outcome is we need to be given, need a fixed probability P of success. Okay. Then the last thing is that our random variable x is the number of trials until the first success. Okay, and if we have all of these conditions, then we can use the density and the cumulative function whenever we please.